Welcome to the next video in the communication topic. This video is going to be looking at 2 dot points. Identify accommodation as the focusing on objects at different distances, describe its achievement through the change in the curvature of the lens and explain its importance, as well as compare the change in refractive power of the lens from rest to maximum accommodation. As we can see in this image, light rays entering the eye from different distances need to be refracted to different degrees to ensure that all the rays fall perfectly on the retina to form a clear and in focus image. So in the first diagram we can see here, if light travels to the eye from a distant source, the light rays tend to be parallel. This means that they do not have to be refracted much in order to pass through the pupil and fall onto the retina. The lens of the eye that can therefore remain in its relaxed and fairly elongated state when viewing distance objects. For distance objects, the curvature of the lens must be relatively flat. The ciliary muscles are relaxed. They hold the suspensory ligaments taut, which are these parts of the eye here. These ligaments pull on the lens, keeping it relatively flat and allowing the image of distant objects to be focused on the retina. However, if light rays travel from a close source, for example, being reflected off an object nearby, the light rays tend to diverge, which means that they spread out. These rays need to be refracted to a greater degree so that they can converge and be directed onto the retina. For this increased refraction of rays, it is necessary for the lens to become rounder, resulting in a focused image forming on the fovea of the retina. The increase in curvature of the lens is brought about by muscle action. For near vision, the curvature of the lens must be increased. A thicker lens has a greater refractive power and therefore a shorter focal length. The ciliary muscles contract, pulling the sclera forward, causing the suspensory ligaments to slacken. As a result, the lens becomes rounder, its curvature increases, refracting the light to a greater degree and allowing a focused image to fall on the retina for viewing near objects. So accommodation is the term used to describe the focusing of objects at different distances, brought about by changing the convexity of the lens and as a result its refractive power. This change in the shape of the lens results from the action of the ciliary muscles, which in turn affect the tension of the suspensory ligaments that hold the lens. So here we can see again, having a look. So we've got our distant light rays from our parallel light rays from our distant object. Our ciliary muscles are relaxed. Our suspensory ligaments are therefore taut, and our lens remains flattened. With close focus, we have our light rays that diverge. The muscles are contracted, so they're tight. That causes the suspensory ligaments to slacken and our lens to become rounder. Okay, so here we can see in the two different types of vision that we have. So in the distant object, the ciliary muscles around the outside of the pupil relax, whereas in a nearby object, those muscles contract. Okay, this causes the sensory ligaments to either become tightened or relax themselves as well, which causes the lens to become thicker when looking at nearby objects or thinner when looking at distant objects. So therefore, the refractive power of the lens changes from low in a flattened lens when at rest to high in a rounder lens at maximum accommodation. When a person grows older, the lens loses some of its elasticity and cannot alter its shape easily. There is a tendency for it to remain in its elongated shape with the muscles at rest, resulting in some people becoming long-sighted, which means that they struggle to see close objects when they get older. A way to remember how accommodation works in the eye is by looking at the letters. So when we have close vision, the muscles contract, so therefore C and C, and the lens becomes rounder, which when you compare a C and an F, a C is a much rounder shape than an F. And then for far vision, the lens flattens. So again, F and F, the muscles are relaxed. Okay, so an R looks like a little F. So that's just one easy way to have a look at how we can remember how accommodation works. And in class, we'll be doing an investigation to look at how the focal length changes in different lenses using a Raybox kit to model the way that refraction and accommodation works in the eye. And that brings us to the end of this video. So thank you for watching.